Hi everyone. So today we want to do just a real quick overview on what are known as algebraic properties. And these are sort of the rules of the algebra road. They sort of get taken for granted, okay, because these are rules that are really kind of common sense when it comes to numbers, and you look at them and you think, oh yeah, well of course I can flip those two numbers around, or of course it doesn't matter what order I add in. But without these rules, our life would be a whole lot harder. So we want to look at just a couple of real basic algebraic properties today and what they do and what they allow us to do and how we can use them to justify problem solving. So the first and probably most basic property we're going to talk about today is called the commutative property. And the commutative property deals with the order of the numbers when you're doing an operation. And the commutative property essentially says that the order of the numbers doesn't matter, that you can switch the order at will, which hopefully you know only works under addition and multiplication. And you're going to see a lot of these properties, quite honestly, really only work under addition and multiplication. A lot of these properties don't play nicely with things like division and subtraction. So the commutative property is essentially what says that 2 plus 3 is really the same thing as 3 plus 2. Okay, it's what lets us change the order of the numbers. Or 4 times 5 is the same thing as 5 times 4. But you'll notice that I couldn't do the same thing with subtraction. I couldn't say 10 minus 6 is the same as 6 minus 10. Okay, that doesn't work, which is why the commutative property doesn't hold for subtraction. Okay, the commutative property works for addition and multiplication only, and it's the property that allows us to change the order of two numbers, which if you think about the concept of addition, it doesn't matter whether you start with 2 and then add 3 more, or start with 3 and add 2 more. You're going to end up with 5 either way. Okay? So that's the commutative property in a nutshell. The next property we're talking about is the associative property. Okay? The associative property, and hopefully in there you see kind of the word associate, means that if you've got more than two numbers that you're doing an operation with, you can change how the numbers are grouped together. So it doesn't really change the order of the numbers. It's different than the commutative property. Okay, this is where the 2 comes first and then the 3, and that would change into the 3 coming first and then the 2. The associative property keeps the numbers in the same order, but it changes what pair of them you do first. Okay, and again, this holds true for addition and multiplication. So this is what I mean. If I have the problem 2 plus 3 plus 5, let's say, I could do the 2 plus 3 first and then add the 5, or I could do the 3 plus 5 first, and that's what the parentheses indicate, and then add the 2 on the end. So it changes out of those 3. Here I'm doing the 2 and the 3 together first. Here I'm doing the 3 and the 5 together first. Notice the numbers stay in the same order, 2, 3, 5, but those parentheses, switching the location of the parentheses, switches where I'm starting the problem. But I'm going to get the same answer either way. Let's see, 2 plus 3, that would give me 5, and then 5 plus 5 is 10. Or over here, 3 plus 5 is 8, and then 2 plus 8 is also 10. Okay? This also holds for multiplication. If I ask you to do 6 times 3 times, I don't know, 4. I could do the 6 times the 3, which is 18, and then multiply that by 4, which is going to be 72. Or I could do the 3 and the 4 first, running out of room, and then multiply by the 6. So I could go 3 times 4 is 12, 12 times 6 is 72. Okay? Again, this would not work if I was working with subtraction or division. But the main difference, and people mix these two up because they have a sort of a similar feel to them. This one, the numbers are physically moved. Okay, the numbers are changed the order. Down here, the numbers stay in the same order. Notice I had 6, 3, 4 here, 6, 3, 4 here. But the location of my parentheses change. It's like I'm changing who's friends with who. Okay? I'm changing that these two associate with each other or these two associate with each other. That's the associative property. Okay, another one I'm sure you've all heard of, the distributive property. And the distributive property, again, plays nicely with multiplication and addition. And we actually say it works for multiplication over addition. And you'll see what I mean by that in just a minute. Okay, so let me show you an example. Let's say I want to add together, I'm trying to use real small numbers here, 2 plus 3, and I want to do that addition problem 5 times. Okay, so I'm going to do 5 times 2 plus 3. Okay, so 2 plus 3 looks like this. Here's 2, here's 3. And so altogether there I would have 5. And then I want to do that 5 times. So I would have, there's 2 sets of 2 plus 3. There's 3 sets of 2 plus 3. There's 4 sets. And 5 sets. Okay? So one row here, this represents 2 plus 3. And then I have 5 of them total, okay? What the distributive property says is I can group these differently. I could say, well, I want to figure out how many are over here total, and I want to figure out how many are over here total. So this would be 5 times 2, because I have 1, 2, 3, 4, 5 sets of 2, and this over here would be 5 times 3, because I have 1, 2, 3, 4, 5 sets of 3. And then if I put those together, that gives me my 25. That gives me my answer that I would have had doing it the other way. Okay? So notice what the distributive property says is I can do this, meaning I can go 2 plus 3 is 5, and then I have 5 of those. Or I can multiply each of these pieces by 5 first, and then add them back together. And I'm sure you've seen a lot of places in math where this distributive property is used. When you're solving equations and you've got a number floating out front, you can either leave it out there or you can distribute it, meaning you can multiply this piece and multiply that piece by that number out front. And that's what you're really doing, is you're saying I have this group and I have 5 of them, and I have this group and I have 5 of them. Okay? So that's the distributive property. The distributive property says this is the same thing as this. Okay, let's talk about some of the new words that you haven't seen before, okay? Probably haven't seen before. So what I really want to talk about here is the I words, identities and inverses, okay? And again, we're sticking in the world of addition and multiplication. And the reason is, really, subtraction and division are just backwards forms of those two operations. So mathematically, if we can figure out a way to do it with addition and multiplication, subtraction and division are kind of just special cases of those operations. Okay, so here's what an identity is. An identity is a number that can be, an identity is a number that can be added or multiplied by another number and not change the value of the number, okay? And I know that sounds confusing, but let me kind of show you what I mean here. Whoops. It's not working like I want it to. Okay, so I've shrunk that up in the corner just to give myself a little more space here. So here's what I want to know. if I take 5 and I add some mystery number to it, what would that mystery number have to be to keep that number a 5? Okay, that's what an identity does, is it doesn't change the value of the number you're looking at. So for addition, the identity is 0, okay? Because you can add 0 to anything and not change its value. 3 plus 0 is 3. 12 plus 0 is 12, okay? So the additive identity is 0. No matter what, if you're working with addition, okay, if you're talking about addition, the identity term is 0, okay? So let's talk about multiplication. Let's say I want to take 7 and multiply by some number and have it still equal 7, okay? Have it retain its identity, okay? It's going to stay the same number. Well, that number would be 1. Okay, because you can multiply 1 by anything and have the value stay the same. So 1 is what we call the multiplicative identity. So there are two different kinds of identities. There's the additive identity and the multiplicative identity. The additive identity is what you would add to a number to keep it the same, and the multiplicative identity is what you would multiply by a number to keep it the same. So that's the concept of identities, okay? Inverses are really closely tied to identities, okay? So it's important that you know what the identities are before we talk about inverses. Okay, so I've got that information that we just found over here in the corner, all right, that we know the additive identity and the multiplicative identity. Let's talk about what an inverse is, okay? An inverse is an operation with a number an operation with another number that turns, an operation with a number that turns another number into an identity. Okay, and that sounds confusing. The thing I want you to really remember here is this is really the process of canceling out. Okay, because once you turn something into an identity, the identity doesn't change the value of anything, and so essentially it makes it kind of worthless. If you turn something into a 1 with multiplication, you can multiply a 1 by anything, and it's not going to change the value. So this is really the process of canceling things out. Okay, so I want to show you what I mean. If I have a 5, let's say, I'm not very creative with my number choices today, and I want to add something to it that would not keep it as a 5 because that was the identity thing, but I want to turn that 5 into the additive identity, which is 0, okay, which basically would cancel out the 5, okay? I could do that with another number too, so I could take 7 and add some number and have it turn into 0. And let's throw a tricky one in here. Let's make this -12 plus something turns into 0. And I want to look for what kind of number turns these things into that additive identity. Okay? And turning it into the identity is essentially canceling it out. Okay? Well, 5 plus what makes 0? 5 plus -5. 7 plus what makes 0? 7 plus -7. Now, -12 plus what equals 0? That would be +12. So what I want you to see is the relationship between these numbers is these are opposites. They have opposite signs from one another. Okay? So for inverses, and I'm going to see if I can move this whole chunk out of the way. Oh, I cannot. That's all right. I'll write over here. The big takeaway here is that the additive inverse is the opposite of a number. Okay, and by opposite I mean opposite sign. Okay, so the additive inverse of 300 would be -300. The additive inverse of -pi would be +pi. Okay, so when I'm talking about an inverse and we're working with addition, an additive inverse is a number that turns a number into the identity, which is 0. Okay? And that's how you cancel a number out, is you turn it into 0, and then once it's a 0, we don't care about it anymore because it doesn't change the value of anything. All right, let's look at this same thing, but let's look at multiplication. So let's look at this same process with multiplication. Let's say I have the number 5, and I want to multiply by something. This time I want it to turn into this multiplicative identity, which is 1. Okay, because a 1 with multiplication doesn't change the value of anything. It's kind of worthless. So I could have 5 times something is 1. I'm just trying to be creative here. I'm not really creative. Let's go with 17 times something is equal to 1. Let's go with -4 times something equals 1. So what could you multiply 5 by to have it equal 1? Now be careful, because a lot of you are thinking, well, I wouldn't multiply by anything, I would divide. You can divide 5 by 5 and have it equal 1. But we really want to stay in the land of multiplication and addition, because that's where all of these properties work. That's where all these properties make sense. Division is sort of a shortcut, okay? Correct answer here, 5 times 1/5 equals 1. Similarly, 17 times 1/17 would equal 1. For -4, it would be -1/4. Notice I kept that negative because I want it to equal a positive 1. The multiplicative identity is just 1. It's not -1. If I had done just a regular 1/4 here, I would have had a negative times a positive, and that would give me a negative answer. So I need another negative to kind of cancel that negative out. So think about what these numbers are called. Okay? These numbers here are called the reciprocal of these. Okay? So, big takeaway there. When I'm talking about a multiplicative inverse, which means the number that you would multiply by to turn a number back into the multiplicative identity, which is 1. Okay, the multiplicative inverse is the reciprocal of the number. So reciprocal and multiplicative inverse means the same thing. Okay, let's put all of these properties into one equation. Okay, and here's what we're going to do. Let's write down an equation here. So we're going to take this equation here, and we are going to solve it, but we are going to say for every step that we take why we're allowed to take it. And you may remember from geometry is very big on justifying each conclusion. That's essentially what we're doing here, but for algebra. Okay? And these properties are the rules of the road that let us do all of these things, okay? It's like we never think about them. We never think about why we're doing the things that we're doing. But without them, we wouldn't be able to do anything, okay? So we're going to solve this, but we're going to identify the properties that we used at each step of the way. And here's the other rule. We are only going to use addition and multiplication, okay? And I'm doing that because notice that all of our properties really only work with addition and multiplication, okay? Division and subtraction are really just shortcuts, okay? They are shortcuts. They are shorthand versions of addition and multiplication. Okay, so if I was going to start to solve this, probably the first thing I would identify is that this 4 and this 3 need to be combined, right? So I probably would not write this out on my paper, but today I'm going to because we're identifying our properties. First thing I would do is probably switch that 2x and that 4 so that I could combine the 4 and the 3. Okay, because I want to add those first. Okay, what did we just do? Why are we allowed to do that? Why can we just flip-flop the 2x and the 4? That is the commutative property. So we all say, thank you, commutative property, for helping me out with that. Okay, I could probably abbreviate that a little bit. Okay, and then I'm going to go ahead and just add that 2x and that 4, so that'd be 2x plus 7 equals 17. Our justification there is that we just did addition. Okay, next thing we want to do is get rid of this 7. And a lot of you are going to look at that and say, that's easy. You would subtract 7 from each side. Remember, though, we are living in this land. We are living in the land of only addition and multiplication. So instead of instead of subtracting 7, let's think of this as adding a negative 7 to each side. Okay? What is the purpose of that? What did we just do right here? Okay? Right there, what we used is the additive inverse. Because remember, the additive inverse takes that 7 and turns it into a 0. So now my equation really says this: 2x plus 0 equals 10. Okay? Well, 2x plus 0 is really just the same as 2x. Why is that? Well, it's because the 0 doesn't really matter. It's because adding 0 to something doesn't change its value. That is the additive identity. Okay, so the additive identity says that if you add a 0 to any number, it doesn't change its value. Okay, now I need to get rid of that 2. And again, probably at this point, a lot of people would say, oh, well, I would divide by 2. But I'm living in a land where there's only addition and multiplication. So instead of dividing by 2, let's think of how else we could get rid of that 2. I would maybe multiply by the reciprocal. Multiply by 1/2. Okay? And the reason I can do that, or the reason I would want to do that, is right here, what I have going on is the multiplicative inverse. Because 1/2 times 2 is really 1. So now this is going to say 1x equals, and then 10 times 1/2 is 5. Okay? And then from there, I would love to just say, well, 1x, that's just the same as x, right? So x equals 5. The reason I can make that jump, the reason I can say, oh, well, 1x is the same as x, is because multiplying by 1 doesn't change anything's value, which is called the multiplicative identity. Okay? So I know that for most of you, if I just threw this equation at you and said solve it, you could do it without writing down most of these steps. Okay? And it's not that I'm going to make you start writing out every single one of these steps, but I want you to kind of start to pay attention to what's going on behind the scenes there. Because this is stuff, or really this is stuff that we don't pay attention to on a daily basis. Okay, even when I'm solving equations, I'm not thinking, oh, I just did the commutative property. But without all of these properties, nothing would work in mathematics. Okay, so these properties are important. They're like the important behind the scenes players that nobody really pays attention to. They really don't get the credit that they deserve. Okay, so now after you've watched this, I would like you to head back to that supplement packet that you received from me on Thursday. If you need another copy, they are up in the front table. And go back to the sections that you didn't do and see if you're able to finish them up now. And I will still take questions on this on Monday, but I'm hoping that this tutorial makes it so that you can finish up most of that packet on your own. Let's say I have an equation that looks something like